Okay, this UK, so indifference curve crossing point A, this one, I said UK. UK is actually like this. UK, the utility level crossing point A. Utility level at point A is 3, 5. This one providing given a certain level of satisfaction. That is UK, right? All the clothing and food consumption providing new, same level of satisfaction to this. That is UK. Then shaped like this. And this one prefer to lower one like this, right? From the perspective of James, higher one prefer to lower one. From the perspective of Karen, higher one prefer to lower one like this. Right? So, point B should be inside of this area. That means both guys' welfare increase when moving A to B. Right? Now think about James' indifference curve crossing point B. That should be like this. Right? That is uj prime, for example, like this. So uj prime higher than uj. So after this transaction, James' utility increase. Similarly, Karen's utility increase. You can draw a Karen's indifference curve at point B, crossing point B. That should be like this. Oh, I'm sorry. James one is this one, right? Originally this one, now this one. That is UK prime. So this one prefer to lower one. So after transaction from A to B, both guys' welfare increase. In other words, Pareto improvement happen. Right? That is explained here. So the adjust box illustrates the possibilities for both consumers to increase their satisfaction or utility by trading goods. If A gives the initial allocation of resources, the shaded area describes all mutually beneficial trade. From here to at any point in this shaded area, James and Karen's welfare increase simultaneously, mutually beneficial trade. Okay, so in other words, Pareto improvement is possible. Okay, even if a trade from an inefficient allocation makes both people better off, the new allocation is not necessarily efficient. When the indifference curves are tangent, right? Tangent, one person cannot be made better without making the other person worse off, right? For example, it's too dirty, isn't it? Right? So I'd like this. And anyway, that is point B. And now think about, for example, this one. Right? That is utility. Yeah, what can I say? Shaded area is this one. Right? And now at certain point, utility level same. For example, at this point, two indifference curve, tangent. Okay, I'd like to draw different way, right? This is A, B, and C, D. At this point, for example, Karen's indifference curve is like this, right? And James' indifference curve is, for example, like this. At this point, two indifference curve, two guys, tangent, right? The tangential of two indifference curve means MRS James is equal to MRS Karen at this point. Okay? Also think about some point D. At this point, that is James' indifference curve, right? And Karen's indifference curve touches at this point. That is point D, that is point C, for example. Anyway, at this point C and D, two guys, MRS, equalized. This one happened. In this situation, for example, at point C, right? After transaction, James' utility can increase from this without hurting Karen. It's not possible. Why? Now think about another transaction. For example, moving to here, then James indifference curve moving from here to here. So James utility increase, right? But at this point, Karen's indifference curve is like this, for example, right? So Karen's one originally here, now here. So Karen's utility increase. What is the meaning of this? At the tangency point, MRS same in both guys. And at this situation, one guy wants to touch higher indifference curve. That happens only when utility level of the other guys decrease. In other words, at this point, at this tangency point, Pareto improvement is not possible anymore, right? Pareto improvement is not possible anymore. That is definition of efficiency in exchanging, right? A certain situation where two guys MRS equalize, thus Pareto improvement is not possible anymore. One guy's utility increase, then utilities of other guys should be decreased, right? That is efficiency in exchanging, okay? If A gives the initial allocation of resources, the shaded area I already explained, right? Mutually beneficial trade. Even if a trade from I already explained this, right? Points C and D are both efficient allocations, although James preferred D to C, Karen C to D, right? At point C, Karen prefers C to D. Why? Karen's indifference curve. C prefer to D because this one is distant from the origin point for Karen, right? But James prefer point D. At this point, James indifference curve higher than this utility at point C. This indifference curve, right? So James prefer D, Karen prefer C. Anyway, at C and D, this condition is satisfied. In general, the allocation that will be reached in a bargain depends on the bargaining abilities of the people involved. Okay, slide number 8. From here, we can conclude, derive contract curve. Contract curve. Then what is contract curve? Too dirty, isn't it? Contract curve showing or efficient allocation of goods between two consumers or of two inputs between two production products, right? Contract curve, originally this one, right? Contract curve is, for example, this kind of thing where, now think about James' indifference curve, right? The point, tangent, currents. This one, and this one, and this one, and this one. So all of this point, every point on this one, right? MRS, James is equal to MRS, current. Two guys, MRS equalize. The point, one point of allocation of two good by two person, this condition satisfied, or a Pareto efficient point. The locus of the point satisfying this condition, that is this one. We said this is a contract curve, right? That is contract curve. The contract curve contains all allocations for which consumers' indifference curves are tangent. In this, so this one, this condition says two indifference curve tangent, right? Graphically, mathematically this one, graphically tangents, right? tangent of two indifference curve. Tangent at every point. So mathematically, this one is perfectly same to this tangency in graphs. Every point on the curve is efficient because one person cannot be made better without making the other person worse. Okay? Every point on this contract curve, what happened? This one is efficiency in exchange, right? Efficiency point in exchange. Because one person cannot be made better, one person cannot reaching higher indifference curve without making the other person worse, without making the other person's indifference curve smaller than before. Okay? That is contract curve and the concept of efficiency in exchange. 19. Consumer equilibrium in a competitive market. Okay? So like this. Also, I'd like to give a contract curve explanation for two-factor case, right? Labor and capital, and food production and clothing production. Efficiency in production, right? So I said LF plus LK is L bar, KF plus KC. KC is K bar, right? Then we can make this kind of HOS box. That is origin point of food production. That is origin point of clothing production. And that is LF. That is LC. That is KF. And that is KC. Right? Then we can find some contract curve like this, where this one, right now think about this. What is this one? Isoquant. We already studied isoquant. Isoquant. Production bundles of labor and capital combination to produce same units of output. Right? That is meaning of isoquant, isn't it? Right? So, for example, that is isoquant for producing 100 food. That is labor and capital combination to produce 80 food. That is Q isoquant for to produce 20 QF. QF is 20 food. Okay? Also, similarly, we can draw isoquant for clothing production. For example, that is, what is this? That is QC is, for example, 10. Labor, lots of some labor and capital combinations to producing 10 units of clothing. Right? For example, what is this? That is QC is 20. That is QC is, for example, 40 like this. So this one is QC is 120 like this. Higher one or prefer to lower one like this. Right? That is then, this is a contract curve in production. Right? Slope of isoquant is MRTS. We studied MRTS. And think about cost minimization problem solution. MRTS LK in food production is equal to MRTS in clothing production. So at some point, the tangent condition satisfied. That means this condition satisfied mathematically, right? Or tangency in graph. Two isoquants tangent with each other. Mathematically, we said this one. Right? That is contract curve in production or technical efficiency or production, efficiency in production. Okay, anyway, in section 2, HOS box and contract curve set, two guys and consumption of food and clothing and indifference curve, right? Two indifference curve equalized, right? And tangency. That is efficiency in exchange, efficiency in consumption. So that graph means efficiency in production or technical efficiency. Okay? And slide number 19. So consumer's equilibrium in a competitive market. Consumer equilibrium in a competitive market. In a competitive market, so the price of two goods determine the terms of exchange among consumers. And this graph, this condition satisfied. Original initial point is here. From transaction between two guys, right? We can move this point or this point or this point, every point on this HS box. How? Bargaining power, right? Bargaining power of two guys or government decision, right? So we can move in any point on here, right? But this slide number 19 says movement from here to at any point on here by price mechanism, competitive market, right? So movement from here to here or here to here, but not by bargaining by two guys, but by market mechanism via price. Can you understand? Now then, think about this, right? Anyway, any point is this one, but led by price, relative price of two goods. So for James, MRSJ for clothing should be equal to PF over PC, right? Also, for Karen, MRTS for clothing, Karen is equal to PF over PC, right? PF over PC, led by relative price of two goods. Anyway, in equilibrium efficiency allocation condition set, MRS is equal to MRS of Karen. This one is equal to this one. Simply talking, efficiency in allocation set this condition, right? But competitive equilibrium in consumption means this one and this one is equal to PF over PC. Can you understand? Right? So you can move at any point on the edge of the box led by price, right? Led by competitive market price. That is this one, competitive equilibrium in consumption. Can you understand? Can you understand the difference of this one and this one? Right? So at this point, we can draw that kind of straight line. The slope of this one is PF over PC when the market is perfectly competitive, right? That is explained here. In a competitive market, the price of two goods determine the terms of exchange among consumers instead of bargaining by two guys. If A is the initial allocation of goods and the price line PP represent this is PP, right? That is PP, for example. That is PP, price line, right? Slope of price line is PF over PC, simply talking, right? So at this point, indifference of James, indifference of Karen, and price line tangent with each other, tangent condition. Mathematically, MRS James is equal to MRS Karen is equal to PF over PC, right? That is competitive equilibrium in consumption. The point of tangential both indifference curve, as a result, the competitive equilibrium is efficient, right? So if initial equilibrium, initial allocation of labor, allocation of food and clothing by two guys are here, and there exists a market, right? Perfectly competitive food market and clothing market. Then we can reaching at this point automatically, led by price mechanism. Can you understand? So that is Adam Smith's invisible hand story, isn't it? Right? An equilibrium is a set of price at which quantity demanded equals quantity supplied in every market. This is also a competitive equilibrium because all supplies and demands are price takers. Can you understand? So now from here, now think about what is, you're familiar with this kind of condition. What is this? That is utility maximization condition. Right? Necessary condition for first order condition of utility maximization. Right? For James. Right? And what is this? This one is utility maximization condition for James. Both conditions satisfied simultaneously. In consumer theory, we studied that James maximizes utility. Right? Utility by food James, clothing James, maximizing utility of James. Right? Subject to PF, FJ plus PC, CJ should be equal to income of James. Right? Rewriting this logic constraint, CJ is equal to IJ over PC, PF over PC, C, FJ, isn't it? Right? That is this one, PP. Right? That is this maximized utility function when price line is this one. Slope is PF of PC. Right? James solved this kind of problem. Then, utility maximizing condition for James is this one. Similarly, Karen solved utility maximization solution. Say FC, CK, FK, PF, FK, PC, CK is equal to income of Karen. Anyway, slope of budget constraint is PF of PC because market is perfectly competitive, right? So this one is budget constraint. So James solved, that is budget constraint, and find utility maximizing point at this point. Two curves tangent to budget constraint touch highest indifference curve. Right? From the perspective of Karen, right? Budget constraint is this one, right? And maximized utility is this one. There are lots of indifference curve, but budget constraint for James Karen is this one. So at this point, this condition satisfied. Right? So at this point, this one, 3 curve, right? 2 indifference curve and 2 budget constraint, right? Tangent at this point. So this one satisfied. So we can find this is a competitive equilibrium. Okay? Before that, I explained by bargaining power of James and Karen, we can reach this efficient point. But if the market of food and clothing is perfectly competitive, led by market mechanism or price mechanism, we can, the two guys reaching at some point where this condition is satisfied. That is competitive equilibrium in consumption. Right? Next slide. The market is in disequilibrium when the quantity of food and clothing demanded are not equal to the quantity supplied. This disequilibrium should be only temporary, led by market price, relative market price. They can find some equilibrium point where this equilibrium disappeared. Excess demand, when the quantity demanded of goods exceeds the quantity supplied. Excess supply, when the quantity supplied of goods exceeds the quantity demanded. In our example, it's current quantity demanded for food. So MRS, that was 3 in our assumption, right? It's greater than each James willing to sell it. That is half or 2, right? Whereas each current willing to trade clothing, that is half, so 2. Is greater than each James quantity demanded. That is half, so James 2. Current is 3, right? As a result of this excess quantity demanded for food and excess quantity supplied of clothing, we can expect the price of food to increase relative to price of clothing. As the price changes, so will the quantity demanded by all those in the market. Eventually, the price will adjust. Right? If there is a price PF is $10, PC is $20. Then anyway, eventually, based on this market price, eventually the price will adjust until an equilibrium is reached. Okay? So next slide. A point C in figure 16.6, the allocation in a competitive equilibrium is Pareto efficient. So this point should be Pareto efficient. Why? I already explained. Right? Point C must occur at the tangency of two indifference curve, or MRS J is equal to MRS K at that point. If it does not, one of the James or one of the currents will not be achieving maximum satisfaction. He or she will be willing to trade to achieve a higher level of utility. At this point, simply talking, Pareto improvement is not possible anymore. One guy's welfare increase, then the other guy's utility decrease. So efficient, right? This result holds in an exchange framework and in a general equilibrium setting in which all markets are perfectly competitive. It is the most direct way of illustrating the workings of Adam Smith's famous invisible hand. So, introduction, chapter 1 and chapter 2 of Introduction to Economics, we introduce Adam Smith's invisible hand, led by price mechanism, right? So all the market can reaching at equilibrium, right? So consumers do their best. Consumers only want to maximize their own benefit, right? They solve utility maximization problem, right? James and Karen solve their utility maximization problem only. Don't care for Karen's utility. James only focus on maximizing James' utility. Karen too don't care about James' utility. Just focus on maximizing utility of Karen. But reaching at led by price mechanism, right? Reaching at this point. At this point, both guys welfare maximize, utility maximize, right? So in a Pareto efficient manner without need for regulatory control. So free trade, free transaction is the best way. Government intervention causes a problem. Okay? So national welfare or consumers' welfare maximize, everything decided at the market. The economic efficiency of a competitive market. The result, the competitive equilibrium is Pareto efficiency, is often described as first theorem of welfare economics. Welfare economics. So in Korean we say 후생경제학. Welfare economics have two important theorems. The first theorem and second theorem, right? Before that, I'd like to explain what is welfare economics. Normative instead of positive evaluation of market and economic policy. That is, right? If everyone trade in the competitive marketplace, all mutually beneficial trade will be completed and the resulting equilibrium allocation of resources will be Pareto efficient. We can reach a Pareto efficient point, allocation, automatically, led by price or market. Okay? Let's summarize what we know about competitive equilibrium from the consumer's perspective. I already explained. Because the indifference curves are tangent, James and Karen's indifference curve tangent, all marginal rate of substitution, MRS of James is equal to MRS of Karen. Because each indifference curve is tangent to the price line or a budget constraint, each person's MRS of clothing and food is equal to ratio of relative price of food in terms of clothing. That is equation 16.1. Slide number 24, utility possibility frontier. What is utility possibility frontier? It's very simple. Utility possibility frontier is derived from this HOS box, right? Contract curve of HOS box. From this one, right? We can derive HOS box. Right? X variable is utility level of James. That is utility of Karen. At this point, now think about James' utility is very small. For example, that is 10, 50, 100, right? James' current utility is 5, for example, that is 60, that is, for example, 120, like this, right? Then, at this point, what happened? James' utility is 10, right? And current utility is 120, so maybe this point, right? How about this point? James' utility is increased to 10 to 30. Current utility decreased from 120 to 100, right? 100, like this. Okay? Every point on this contract curve converted to one point on this graph. For example, at here, 50, 60. James 50, current 60. 50, 60. So, like this. At this point, James' utility is 100, current utility is just 5, like this. If we connect all of these points, we can get this kind of utility possibility frontier, right? The utility possibility frontier is directly calculated from this contract curve in this Edgeworth box. Can you understand? Similarly, from here, we can define production possibility frontier from this Edgeworth box, right? At here, production of food, production of clothing, and MRTS is like this. Okay? Then now think about X variable. From here, X variable is QC, right? Clothing, QF, food production, and Y variable is clothing production, right? This Edgeworth box, what happened? For example, QF is 10, right? And clothing production is, for example, 200, right? So at this point, food production increased from 10 to 20, and clothing production decreased from 120 to 100, like this. At this point, clothing production is 70, right? Food production is 70, clothing production is 40, like this. At this point, food production is 100, clothing production is 10. If we connect this, we can get this kind of production possibility frontier, right? In production possibility frontier. So production possibility frontier is derived from a contract curve in Edgeworth box of labor and capital in food and clothing production, right? That is Edgeworth box. Okay? Anyway, we back to consumer theory again. Utility possibility frontier, right? Utility level of James, utility level of current, Y variable is current utility. That is equation 16.8. So utility possibility frontier is curve showing all efficient allocation of factors, allocation of goods, in this slide, measured in terms of utility level to individual. The utility possibility frontier shows the level of satisfaction, in other words, indifference utility level, measured by indifference curve that each of two people, James and Karen, achieve when they have traded to an efficient outcome on the contract curve. Point EFG corresponds to point on the contract curve and efficient. Point H is inefficient because H is inside of utility possibility frontier, right? H is inefficient because any trade within the shaded area will make one or both people made better. Now, you are located at point H. Then this shaded area of EF line, right? You move in EF line, utility of both guys, James' utility and Karen's utility can increase simultaneously, right? So in that sense, point H is inefficient. And point L is above this utility possibility frontier. That means in L, point L, utility of Karen and James increase. but not feasible. Simply talking at point L, right? So this condition cannot be satisfied. Put Fj plus Fk is 10, Cj plus Ck is 6. But point L is not above this condition. Maybe food should, to reaching at point F, food is increased to 10 to 15 and clothing is 6 to 10 like this. Right? In that sense, it's not attainable. Okay, in figure 16.8 in slide number 25, H represents an inefficient allocation because any trade within the shaded area makes one or both parties better off. At point L, both people would be better off, but L is not attainable. I already explained. An allocation must be Pareto efficient to be equitable. Pareto efficient allocation must be Pareto efficient to be equitable. It is inequitable to James or Karen or both for an economy to yield allocation H as opposed to F or E. Compared with H, G yields more utility for James, less for Karen. Some people may feel that point G is more equitable than H. Others may feel the opposite. We can conclude, therefore, that one Pareto inefficient allocation of resources may be more equitable than another Pareto efficient allocation in some times, right? Considering point H. The problem is how to define an equilibrium allocation. The answer depends on what one thinks equity entails. So it depends on definition or your preference. So in that sense, welfare economics is normative one instead of positive one, right? So to evaluate this, we can define social welfare function in slide number 26. Social welfare function measure describing the well-being of society as a whole, in terms of utilities of individual members. A social welfare function is useful when we want to evaluate policies that affect some members of society differently than others. One such function, the utilitarian ways. So first one is utilitarian approach. This means this function weights everyone's utility equally. All persons, all individuals' utility, right? Treated equally with same share, same ways. And consequently maximize total utility of all members of society. So just focus on maximization of total utility of all members. Right? Each social welfare function can be associated with a particular view about equity. For example, a market-oriented view argues that outcome of competitive market process, for example, MRS is equal to P1 over P2 is MRS James, right? This outcome of competitive market process is equitable. That is market-oriented view, right? All the Pareto efficient allocation is equitable because it rewards those who are most able and who work the hardest. Work hard, more hours of work, receive more wages. More able person means more productive person receive higher wages than the other, for example, right? So E would be deemed to be more equitable than F, even though goods are less equally allocated. That is market-oriented view. So until now, we studied two types of approach on social welfare function. First one is utilitarian, right? This approach weights everyone's utility equally, okay? And market-oriented view is competitive market outcome is just equitable, okay? And third approach is the Rawlsian view. When more than two people are involved, the meaning of the word equity becomes even more complex. The Rawlsian view considers a world in which individuals do not know what their individual endowments will be. Right? You don't know how rich you are. Right? Specifically, according to Rawls, the most equitable allocation maximize utility of the least wealthy person, utility of poor persons, right? That is utilitarian view. Just focus on equitable allocation means maximization of utility of least wealthy person, poorest person, simply talking. That is Rawlsian view of equity. The Rawlsian perspective could be egalitarian, in the sense egalitarian, involving an equal allocation of goods among all members of society. But it need not be. Suppose that by rewarding more productive people more highly than less productive people, we can get the most productive people to work harder. This policy could produce more goods and services, some of which could then be reallocated to market for poorest members of society better. That is a market-oriented view, based on market-oriented view. Anyway, market-oriented view means able person, more productive person, and more person work more. The person who input more laborers receive more income. Anyway, in this market-oriented view, maximize total production, right? Maximization of production. After maximize production, some goods can be reallocated to poor people. Then poor people's welfare can increase. Okay? That is the idea of market-oriented view. So, table 16.2 summarize 4 views of equity. Number 1, egalitarian view. That is socialist view. All members of society receive equal amounts of goods, consume same amounts of goods. Rawlsian view is maximize utility of the least wealthy person, maximize utility of poor people. Right? Third approach is utilitarian. Maximize total utility of all members of society. Right? So individual utility is treated in the same way. Right? Weight of individual utility are perfectly same. So maximize the total utility of all members of society. Market-oriented view, the market outcome is the most equitable because production, after maximizing production, right, reallocated to poor people. The 4 views of equity in table 16.2 move roughly from most to least egalitarian. While the egalitarian view explicitly requires equal allocations, the Rawlsian puts a heavy weight on equality. Otherwise, some people would be much worse off than others. The utilitarian is likely to require some difference between the best and wealthy members of society. Finally, the market-oriented view may lead to substantial inequality in the allocation of goods and services. Okay? Economists prefer market-oriented view. And rich countries like United States or European countries emphasize the Rawlsian some approach. Socialist countries prefer egalitarian view. I don't know. How about Korea? Evaluate for yourself. Okay, and equity and so last slide, equity and perfect competition. A competitive equilibrium can sustain every point on the contract curve. This outcome suggests an answer to basic normative question. Is there a trade-off between equity and efficiency? Is there a trade-off between equity and efficiency? The answer, which is given by second theorem of welfare economics. Right, I already explained first theorem of welfare economics. Second theorem of welfare economics said redistribution need not conflict with economic efficiency. Formally, the second theorem states the following. If individual preferences are convex, then every Pareto efficient allocation, every point on the contract curve is competitive equilibrium for some initial allocation of goods. Literally, the theorem tells us that any equilibrium deemed to be equitable can be achieved by suitable distribution of resources among individuals. Anyway, Pareto efficient point means something efficiency happen, right? After that kind of allocation achieved, then we can redistribute this one to increase equity, right? So equity and efficiency is not compatible with each other. It's compatible with each other, right? No inconsistency between, no trade-off between efficiency and equality. Okay? So after suitable redistribution of resources. Unfortunately, all programs that redistribute income in our society are economically costly.